Eh, okay. So now it's okay. So, so previously, what I said that previously we finished with this anomaly detection, and now we are going to start this semi-supervised learning, which is the third category of the types of machine learning algorithms. So from the word semi, normally when you have this word semi, so it is always means that it is in between, huh? So semi-supervised learning, before that we have learned supervised and unsupervised, and this is semi-supervised. So then it would be the combination of supervised and unsupervised, both approaches. And now according to this diagram, so we are going to state something here. So if you will see the diagram here, first let's have a look on this, that here we have some labeled data. So this is a data. Some data instances or some data examples or samples are labeled with red and some are blue. So this red and blue is the label, okay? And then here in the first step, we are going to train the model with this labeled data. So this is supervised approach. When you are going to train your model with the labeled data, this is supervised approach. Okay, so this is supervised learning. And then we have unlabeled data. This gray is unlabeled data. So now on this labeled data, our model is already trained. Now this unlabeled data. So we are using this unlabeled data like test data for this model, for this model. And then this model is giving us the labels for this unlabeled data here. And here we are calling it pseudo labeled data. So that data is now, when you will run this model on this unlabeled data, it will give you this labeled data. Now, previously you have this data, which is represented again here. And from here, you are getting this data. So now you are merging it again. Merging it again and making again a data set like that. And then you are training your model again like this previous step one that you have done there. So now that step is a little bit explained here. So initially we will use small supervised learning component. Small supervised learning component like that, small label data, and then by using that small label data, you are getting the training of that model. So small amount of pre-labeled data you will use initially, and large amount of unsupervised learning later on. So this picture is now giving you an idea that how you can combine the supervised and unsupervised techniques together, where you have the labeled data and also the unlabeled data. So in this semi-supervised learning, so then you can finally say that in this approach, we will use small supervised learning component, and that component will use small amount of data, labeled data. And similarly, you will have large unsupervised learning component that will use large amount of what? Data, unlabeled data. So, okay, now people who are implementing semi-supervised models, they are adopting these two approaches for building these models. In the first model is same that you are seeing here, or that you already have seen here. The first model is the same. So in the first approach, we will build the supervised model. We will start with a small amount of label data. Then we will build unsupervised model with large amount of unlabeled data to get more labeled samples. Like here in the diagram that you have done here. And then you will train the model again on that pseudo label data. And then you can keep on repeating this process. So that step is very much similar to this step which is explained here. Now look over here in the second approach. We will use unsupervised method. Initially, here we were using label data, which is supervised. And in the second approach, here we are using what? Unsupervised method approach. It means our data is what? Unlabeled. It means our data is what? Initially, our data is unlabeled. So we are using unsupervised methods to cluster similar data samples. To cluster similar data sample. If you will go there in the unsupervised, you have first category clustering. And this was the image. This was the image which is giving you that concept. So here in the second approach, we will use unsupervised models. It means our data is unlabeled. And then we will use the clustering approach. And then we will have our data divided into clusters, into groups. That groups are basically the labels of that data. And then what? So when we have those clusters, then we will label these clusters. We will label these groups. And now our data is what? Labeled. Our data is what? Labeled after using that unsupervised approach. Now we will label these clusters and then we will use a combination of this information. So now our data is labeled. Now we will use supervised learning model to train our model. But initially our data is unlabeled. And there you use unsupervised model. You used unsupervised model to get the labels of that data. When your data is labeled, then you are again using unsupervised. So that is that second method. So through these semi-supervised learning methods, you can, hey, these are some examples here. You can do the text classification or you can do the image classification. For example, you have images of animals and then your model is doing what? Classifying uh, uh, different animals into categories. For example, you have the pictures of different species, or you can say it is a mixture. You have cows, goats, or maybe spiders, maybe snakes, images you have. And then your model is what? They are differentiating these different species, or it is categorizing the animals. So that can be through image classification. Text categorization, text classification is spam, not spam. Anomaly detection, you already know, etc., etc. Now, the fourth category of types of machine learning algorithm is reinforcement learning. What kind of model these are? So this is the structure of the model is given here in this picture. In this picture, the computer program that you will have, you will call it an agent. You know already from the CLO1 in the course, because all the programs that you will design in AI, you will call them agent. This is what you learned in first chapter. So that's why now, so that is more close to, basically this reinforcement learning is the proper approach of AI, which machine learning is now also saying that it is our approach. Machine learning itself is the part of subdomain of AI. Anyhow, here you can say that this is an agent. Agent will first observe. This is the environment of the agent. And this is the input to the agent. And input to the agent is the data which is containing squares, red stars, and the blue stars, and a mixture of it. So this is the data. And this agent is taking anything from the data, any state. And then from the algorithm, agent has the algorithm. from the algorithm, then agent is performing some action on that state in the environment. If that action is okay, then agent is getting reward. If that action is not okay, or which means it is after performing that action, you are not getting what the agent wants, huh? What the agents want, if the agent is not getting that thing, then then the agent will have a penalty here. If the agent performs well, then the agent will have the reward. And if the agent will not perform well, then the agent will have penalty here at this point, But here we can write only one word, or you can say reward or penalty. Reward oblique penalty, huh? And if it is okay, if the agent performs well, and you are on now on a good state now, the next state, which is better state, then the agent will also update its policy. Okay, I performed well. Okay, plus 1 point, huh? Reward is given. And if agent does not perform well here, then agent will get the penalty. And this action, then the agent will learn that this action that it has done, it does not have to do this action again. And then it will update the policy in the algorithm here, because the agent got the penalty. So in this way, this is a circle which is going on there. And agent will run on this data one by one, and it will get each instance one by one. And if the agent is detecting square, if agent is detecting square, it is getting reward. If the agent is identifying this square correctly, agent is getting reward. And if agent is not identifying this square correctly, it is saying that it is a star, even it is a square, then it is getting penalty. And in this way, these trials are going on for all the instances. And whenever the agent will get rewards, it will learn. It will more strengthen the algorithm there. And whenever after penalty, the agent will learn that the agent does not have to do this again. So the agent will update this penalty action also here. And through this reward and penalty, the agent will learn. And finally, it will give you the output, all these data separated into proper groups. So this whole discussion is called in reinforcement learning. So the agent will get training over a period of time in some environment. Then the agent will have a set of strategies initially. That set of strategies is the part of this algorithm, okay? Set of strategies. When this state will come, what action is the agent has to take? This is strategy, yeah? After observing the current state, it will perform some action, and then it will get reward or penalty. Based on this reward or penalty, the agent will learn what to do and not to do. Now, this is just an example here that we have an agent here, and this is the environment. In the environment, the agent has the fire and the bucket, and here we have a water tap. Here, initially, the agent will observe the environment. The agent will observe an environment that here in the environment, fire is on one side, which is going on there, and how the fire can be set off through this water. But now, what the agent will do? Either the agent will move towards the right-hand side toward this fire, or toward the left-hand side toward the water tap. So the agent will observe this first. And then after observance, now in the second step, the agent is selecting some action from the algorithm. Using policy means from the algorithm, the policy that algorithm has. So for example, the agent has selected move left, huh? So then the action performed. So then the agent or move right according to the according to this is right, this is left, if. So if the agent is performing, okay, move right, and okay, here the action is performed, and here going directly towards fire without water is what penalty. So this is, now it is getting reward or penalty. And then from this penalty, now the agent will learn that next time it the agent does not have to do this. So then what? The agent has to update its policy. So that is the learning step. And then step 6, iterate until so now keep on doing that until you have your policy optimal. These steps are rewritten here in general words. In general words. In general words, here main step in reinforcement learning. Here the agent will prepare with the initial set of strategies with the algorithms. Step 2, observe that, then it will observe the environment and its current state. And it will select the optimal policy. It will select the action from according to this current state. From the optimal policy, it will select some action and perform that action. And step 4, getting reward or penalty according to that action. Step 5, updating the policy. If penalty, updating the policy. And step 6, repeat 2 to 5. Almost similar, but in general words. So the people who want to understand this diagram, they can also read these steps, or after reading these steps, they can read this diagram and they will understand what this diagram is saying. Now, this is just a flow diagram that after looking into your data, how you can decide that what method you have to apply on this data. So for example, if you have a data and in your data, if your data is correlated or redundant, redundant means in data you have repetition. Correlation, in data, you have one column dependent on another one. Huh? So if you have these types of things there in the data, if answer is yes, you have to reduce the dimensionality. We have studied some dimensionality reduction. We got the introduction there. By using that PCA algorithm, principal component analysis, you can reduce the size size of the data. You can reduce some columns from the data. That is what dimensional reduction means. And then you will come back here at this step. But if your data is not correlated and are no redundancies there, then you are going to check another question, that is data producing a category in your data? Is there anything that you are getting some category? For example, the data about some emails spam, some are not spam. So this spam or not spam is category. So do you have that category there? We studied that what is category there. If the category is yes, then you are checking another question in the data. Is data is labeled? Is your data is labeled? Labeled means the output that you want is available in the data. If the answer is yes, then do the classification. If the output that you want is not available in the data, then go with the clustering. Go with the clustering. Clustering is unsupervised. This is supervised. Now coming back here, is data is producing category? If yes, then this is the thing. If not, if there is no category in the data, then you are checking another question. Is data is producing quantity? Producing some quantity. Quantity means some value in numbers. Huh? It can, for example, 25 items, 30 items, 60 items. What I'm saying some quantity. Yeah. So is data producing some quantity? If answer is yes, use regression. Just remember that example of price of the houses. Continuous data. So use regression. If no quantity, then bad luck. Then it is what? Salamu alaikum. Okay. Then, then no solution. Even then you can do something with that. That is not an issue. But according to this diagram, okay. Now we are going to see some, as an example of machine learning, we are going to see some algorithm. And that algorithm, for NLP, you have seen minimum error distance. And now for machine learning, we are going to see the first algorithm, naive Bayes classifier. That is used for classification. And the example is spam, not spam. Huh? Spam, not spam. So this naive Bayes classifier is a probabilistic classifier, is a statistical classifier. When you have the word statistical, probabilistic, it's almost same meaning. So naive Bayes is what? A statistical classifier. And it is lying in the category of what? Supervised learning. And naive Bayes. Bayes is the name of the theorem which is available in statistics. Bayes theorem. Bayes theorem. So, and this theorem will work on the conditional probability. And if you remember the discrete mathematics, you have studied this conditional probability there. Conditional probability is always that thing in which you have to find the probability and something will be given to you. For example, you have to find the probability of event E given some event. Or if I say probability of, it is written there already. So probability of A, this means given, B is given. So due to that given, we normally call it conditional probability. And now the equation for this naive Bayes classifier, according to that Bayes theorem, is probability of A given B is equal to probability of B given A multiplied by probability of A and then probability of B. So if you want to calculate the probability of this thing, you are in need of probability of B and A, probability of A and probability of B. If you can calculate these things separately, then you can put these things here in the equation and you have your answer. You have your answer. Now we are taking an example here. And in this example, we will predict by using this naive Bayes classifier. We will predict according to the algorithm of this naive Bayes classifier. We will predict what? A person will purchase a product on a specific combination of day, discount, and free delivery. This day, discount, and free delivery, which are columns, and their values are given here. Day has the weekday, weekend, and holiday, 3 values. Discount is yes or no. Free delivery is yes or no. So based on this data, now we have to predict that the person will purchase a product or buy a product on some combination of day, discount, or free delivery. And we have to predict this using naive Bayes classifier. So then how you can do that? Because Bayes theorem has probabilities. So we need probabilities of these things. We need probabilities of these things. And then we can decide that either the person is going to buy or not buy. So we moving next. This is now our data. Yes. These slides are available. I have uploaded recently and you have on your computer, 1 month before you downloaded it. So now download it again and you will have these things there. Okay. Sorry, now this thing is recorded. Okay. And you will enjoy. And I will also enjoy when later on I will listen sometime. Huh? So, so this is this is available in the slides. Okay. Maybe you have downloaded this content 1 month before, so that's why you are saying that it is not available in the slides. So now, this is our sample data, which is containing 30 rows, but here we have displayed only 15, okay? 15 rows are displayed, but you have 30 rows, huh? And here you have one column day, another column discount, another column free delivery, which was these columns, huh? And now what you want to predict? These are the inputs of your model. The things which are input of your model, this is called independent variable. Okay. And the things which are output of your model, these are called dependent variables. Another name. The people who are under studying machine learning with me, they know that what is independent and dependent. So anyhow, so we have to predict buy or don't buy. And whatever you want to predict, that must be the part of your data set. So that purchase means buy, huh? Here it is the title purchase, buy, same thing, okay? And the value is yes. What it means on the weekday means Sunday, Monday, Tuesday, huh? And weekend means maybe weekend means day before Sunday, huh? Saturday or Friday, huh? And holiday means if sometime you have the holiday, huh? So if the weekday is yes, and free delivery is also available, yes, and we are on Monday or something, is it the possibility that we are going to buy or purchase something? This is what it means, huh? This is what this row means. Now we have these, and you have this data like that, in which you have this different entries. Now, what is next step? So these are the 15 rows only displayed, but we have actually totally 30. Now, what you have to do here by using this knife-based classifier? First, you have to, according to equation, you have to calculate probabilities. We cannot calculate probabilities until we have the counts. So now the artistic word for the counts is frequency. So now you have to calculate the frequency of each and everything before actually you will calculate the probabilities, and then the conditional probabilities. Conditional probabilities is you will calculate a probability given something. Simple probability is calculate the probability of this thing without giving anything, okay? So now first you have to calculate the frequency, which is count of different things. And from the data, and from this data, now for example, for this discount variable, and that discount is here. And now here you have yes and no values, and here you have in the output, you have this is output. This is what we want. We want to buy or not buy. So now you have to build a frequency, or you have to calculate the frequency of this discount and purchase. For that reason, you have this table there. When the discount is yes and when the discount is no, are you going to buy? This yes means when the discount is yes, you are also going to buy. Buy means purchase, that column. Buy means this column, okay? This is buy. Okay, this is buy. So when discount is yes, your guess, this is one entry. This is two entry. Count this. Yes, yes, 3, 4, 5. In this way, you will count. When you will count, when discount is yes and when the buy is yes, it is how many times? 19 times in that data. When the discount is yes and the buy is no, how many times? Only one time. When the discount is yes and buy is no, okay, this is no and here no. This is no, here no. No, no, and we don't have the total 30 rows there, okay? So only one evidence. So only one evidence that when the discount is yes and the no is only one evidence from the data, one row. When the discount is no and the buy is yes, 5 5 evidences from the data. I will give you a complete 30 table if I will give in the exam, okay? Or I will give you only 15 which are here, okay? Or maybe I will give you some other data set. And if the discount is no and you buy is also no in the data, how many times? 5 times. I hope you understood how these values are calculated. How many students have calculated, understood? Raise your hands, please. The students who are busy with their phones, they even don't know what question I have asked, okay? And what is happening with you? Your name is what? The last. Huh? Innocent. You are innocent and not understanding anything, huh? And not understanding thing. So you are purely depicting the personality as your name is, huh? You can say, I am innocent. I am not understanding anything. Do not do any zulm on me, huh? So then we have another table that is called free delivery. So now free delivery is this thing. Free delivery also has yes and no values in the data. Now we have to design this free delivery with respect to this buy or purchase. And now here we are saying when free delivery is yes and the purchase is also yes, how many times there in the data? So you have to match. So 1, 2, 3, 4, 5. How many times? And then you are saying 21 times in the data. And when the free delivery is yes and the buy is no, how many times in the data? 2 times. And similarly, this is 3 times, 4 times. Similarly, you can make this table, frequency table for the day and the buy. And day is what? Day is this. And buy is the same. Buy is the output. Huh? And you have to, and what it means, when we have the weekday, normal days of week, are you going to buy? How many yeses are there in this column buy? So when you counted, you got 9 times. And for no, 2 times. And for weekend, on weekends, how many people buy with the yes in the data set? When you count it from here, and then if you will get it 7 times. So now you have prepared all these frequency tables first. And this is what? These are the independent variables, and this is dependent. This is independent, this is dependent. This is independent, this is dependent. So you have to make frequency tables of all independent variables with the dependent variable. You have to make it ready for calculating probabilities. The other name for probabilities is likelihood. To calculate the likelihood or probabilities, you need these frequencies, because only then you can divide that count with that count and you will get that probability. Huh? So now we are assuming, according to Bayes' theorem, for this data, we are assuming that our buy or purchase, we are saying that it is A. And then our independent variable discount, free delivery, day, we are calling them B, because now we want to get close to our equation. And in equation, we have the A and B. And now we are now saying that this purchase is now A and all others are what? B. B are independent variables, and A is what? Dependent variable, which we are saying here according to the Bayes theorem. Here we are saying discount, free, and day. Here we are saying it B. And this and this buy, we are saying it A. Moving next. Now we are taking a simple example. How now? First, we will calculate the likelihood, which means probability. And then we will calculate the conditional probability, okay? There is a difference between probability and the conditional probability. And you know what is that difference, huh? How many students know what is the difference between the probability and conditional probability? Raise your hands, please. 1, 2, 3, 4, 5, 6, 7. Less than half of the class, huh? If you have to calculate only probability or likelihood, then something you only have to calculate that probability without any given thing, huh? For conditional probability, some given thing will be given to you. For example, this equation, this is the equation, B is given. When B is given, then this is conditional probability. And if you are calculating here, probability of A, no anything is given. You have to calculate the probability of A only. So this is called simple probability or likelihood. This is not conditional. This is not conditional. This part. Here, this part is again conditional. This part is what? Probability simple or likelihood. So now, where I was here. Now, after making this A and B, now we are ready to calculate the likelihood, which means now we are ready to calculate the probability, not conditional probability, only probability. And we are going to calculate the likelihood for the day, Day is one frequency table here. This is day, or this is the table for the day. This is frequency table for the day and by. So we are going for the day now. We are going to calculate the likelihood for the day table now. Day. So now this is day, week, weekend, by. So what do you have to do? First, what is the frequency table? This was the frequency table. I copied this table as a same copy here. These blue things are extra only. So what do you have to do? You have to sum this up. When you will sum them up, you will get 24. Sum them up, 24. This is the count. This is the frequency. And sum them, you will have 11. Sum them, 8. Sum them, you will have this. Total is 24 and 6, 30, and if you will add them, you will have that 30. That 30 is your total rows. That 30 is your total rows. And all these entries, when you will sum them up, it is becoming 30. Because this is the count of different entries that you are identifying in the database and then writing it here. So this is only the count. Now we have to convert this count into likelihood, into probabilities. How you can do that? So here it is 24. So 24 divided by 30, total number. 24 is the entries here, in this column. I can remove this drawing. So this is 24 is the entries here in this column. And when you will do 24 divided by total 30, total entries, 24 divided by total entries, then you will get some fractional value. Huh? That would be the probability. And similarly, here, when you will divide this 6 rows with 30, you will get again some likelihood. And similarly for all, 11 by 30, 8 by 30, 11 by 30. So what it means, actually means is when weekday is yes and buy is no, huh? You are not buying, then what is the probability? This is the probability. If you want to understand. When weekend is yes and buy is no, what is the probability? This is the probability. When holiday is yes and when buy is no, this is the prob. And for this 24, when buy is yes on any day, what is the probability? This. When buy is no on any day, what is the probability? This. This is the meaning, theoretical meaning of these sentences. But in steps, you have calculated first frequency. From that frequency, this is how you can calculate the likelihood. Likelihood is the simple probability. Now, Now we are moving towards the conditional probability. We are going to calculate the conditional probability. This is we did only for the day. You can calculate this likelihood for the day, for the free delivery, for the, so for the day you have done. You can calculate this likelihood for the free delivery, for the discount table also. But here there are three tables, but here you have done this step only for one table. You can perform this step for three tables. Now, moving towards conditional probability. So the day with its frequency is this, and with its likelihood is this. We copied this slide here again, nothing else. Now, what is our equation? Our equation is probability of A given B, probability of B given A, reverse, multiplied by probability of A, divided by probability of B. So it means that I have to find first probability of A, probability of B, and then probability of B given A. I have to find this first. So that's why I am calculating probability of B. B here. Probability of B here. What is my B? My B is containing day, weekday, and also what? Here, B is containing what? Discount, free delivery, and day. You can separate them or together, no issue. So, and here A by means A or not by is also A, okay? So, probability of B with respect to now, with B is what? Free delivery, day, and discount. And here we are only concerned with day. We don't have free delivery and discount, okay? Just to make the things easy, huh? Then you can do the same thing again for then discount and then for the next tables. Huh? Here we are doing this only for one table. And here we are taking the first value, weekday. Probability of B, day has the value this. Day has three values. These three values are the values of this day table. And this yes and no are the two values of this purchase or buy table in the data set. And now probability of B is what? Okay, weekday, probability of weekday. Probability of weekday, we are not concerned with yes, no, huh? It means whatever the buy is, we are not concerned. Huh? So probability of weekday only. So then it means this. Huh? We are not concerned with yes or no. Given yes or given no, no, we are not concerned. So then 11 divided by 30. 30 the total number of rows. Then you will have 0.37 is the probability for the B. Similarly, probability of A. And here we are saying no buy. You can also say buy here, no issue. Probability of no buy. We are no buy. So no buy is what? This is no buy. This is what? No buy. Here, if your A is no buy, you are not going to purchase. You are not concerned now with any day, huh? So you only have to think here. So total is 6. 6 divided by 30.2. Now probability of B given A. Now you have calculated A. You also have calculated B. And then probability of B given A. Probability of B given A. Maybe some person can divide this 0.37 with this 2 and get the answer, huh? No, you have to go along with the formula, okay? So what is probability of B? B is what? Weekday. And A is what? No buy here. You just replaced, and what it is saying? Probability, you have to calculate probability of weekday. Given is what? No buy. Given no. So weekday, now weekday given no, which is this entry. Which is this entry only. 2. So what it means? Weekday is this entry. And given what? No buy, which is this one, no buy. So this entry. And what are the total given no buy? Total six. Total six. So no buy is given. And what are the total number of no buys? Six. So that's why that six is coming from here due to this given. And weekday is what? Here, here in this no buy category, this weekday is coming here and joining here. So only two. So that 2 by 6 is now giving you 0.33. Now all the three things are ready to put it into the equation. So this is the equation A divided by B. If you will convert it in theory probability of no buy, A is no buy, B is weekday, and then it would become, this is the opened form of this equation. This is the closed form. This is the opened form of the equation, which is weekday divided by no buy, probability of A, which is no buy, and divided by probability of B, which is weekday. Now put all these values here, calculate them, and you will have 0.18. 0.18. So now the probability of no buy given weekday is, if it is less than 0.5, it is 0.18 less than 0.5. 0.5 means 50%, huh? And it is 1.8, which is less than 0.5. It means that on weekday, we are not going, the probability of no buy on weekday is what? No buy is not going to occur because the probability is very less that no buy will occur on a weekday. The opposite will occur, huh? What it means? It means the opposite will occur. And the opposite of this is buy. So the event of buying a product on a weekday is now most likely to occur here in this situation. In this situation, huh? Now we are changing our example. Previously, we have only one prediction, weekday, no buy, one with one, okay? Now we are taking multiple in the given condition. Here in the given condition, you have only one given condition. And here now our B is what? Our B will contain day, discount, and free delivery. We are considering three together as given, huh? Previously, there was only one. Now, in this example, we are considering what? Three given things. And then we will calculate the probability of one thing. And now our A is what? Again, no buy or no purchase. But given is what? These three. We copied all the tables here. All the tables here from that previous data. We copied all that. This is with the likelihoods. This is with the likelihoods, nothing else. So now look over here, all these tables again. And now by using the Bayes theorem, we have to calculate probability of A given B. Our A is what? According to this, A is what? No buy or no purchase. And this is B. So probability of A given B, this is what we want to calculate. So probability of no buy, A is no buy, and B is what? Discount is equal to yes, free delivery is equal to yes, day is equal to holiday. This was the B which is written here, huh? Okay, now how we can calculate? So when you will have multiple given conditions, how you can deal them with? Actually, you have to calculate probability of no buy with the discount is equal to yes. First you have to calculate this, which is written here. Probability of discount is equal to yes given no multiplied by probability of free delivery yes given no. Why I am reversing the order? Because in the equation you have probability of B given A on the right hand side. Again, Here you have A given B. Here you have B given A, reverse order. Huh? And here, if somebody is, so this is B, discount yes, and I am reversing the order. Probability of discount is equal to yes given no. And then for that, probability multiplied by probability of free delivery yes given no. And then for last one, multiplied by probability of day is equal to holiday given no. Multiplied by only the last A, probability of no by. According to the equation, probability multiplied by probability of A. This is probability of A. And this whole thing that you have here, it is basically probability of B given A. Written separately for each component. Because my B is what? This is my B. Now, probability of discount is equal to yes, multiplied by free delivery yes, probability of day holiday yes, this is my B. So we are writing B here, nothing else, with multiplication. Now, how many how many students have understood up to this point? Raise your hand, please. Okay, good. So now probability of discount is equal to yes given no in the discount table. In the discount, this is discount. Probability of yes given no. So this entry, huh? This entry. Similarly, probability of free delivery yes given no. Free delivery here. Probability of yes given no. Here, this entry, which is written here. And then probability of holiday given no. Probability of holiday given no. 3 by 6. This entry. And then probability of no by only, without giving anything. No by, no by. Probability of no by. So no by, this is by, and day without any day. So the total, so you will go with the total. 6 by 30. Total no, huh? Which is here. And then probability of yes only. Probability of yes, discount is equal to yes. Okay, go into the discount. Probability of yes only here, without considering yes or no, okay, because you are not seeing given. So this value 20 by 30. Probability of free delivery yes. Free delivery yes. Free delivery is where? Here. And the yes is what? 23 by this one. And similarly, maybe this one. 11 by 30 here. After evaluating, you have this answer. This is for the no by with this. And now your A is what? By. Not no by, okay? And B is same. B is same. Then what is the equation? Probability of yes by. Huh? By means yes by. So you don't have to consider no now. You will have to consider yes now. And the B is same. And this equation is same. Discount yes, given yes. So we are writing similar like that, but we don't have no here. So discount yes, given yes. Free delivery yes, given this. Then this, given this. So these are the three things there. And probability of A, that would be this one, which is A. And the probability of B, similar. Count it from, for example, here. Discount yes, given yes. So in the discount table, if I will remove all the drawing, now discount yes, given yes. In the discount table, when discount is yes, buy is yes. What is the entry? What this is the entry? 19 by 24. And this way you can get all these values and you have this one, 0.94. This is the conditional probability for when you are going to buy. And this is the value when you are not going to buy. Now we have the probability of not buy and the buy. Now you can do some further normalization with it. Otherwise, you have these probabilities. So if you want to normalize, you can sum these two probabilities, the probability of not buy and buy. Sorry, this is not buy, this is buy. So probability of buy and not buy. If you will add them, you will get this total probability, which is not one, which is becoming more than one. Okay. But anyhow, leave it. It is not too much. So that's why, okay, go on with that. It is sum of probabilities. It is not something where you have to, by the way, it is buy or not buy. It should have to be one, huh? But it is becoming more than one because it is an example. Because those examples there, whatever you have. So now, likelihood, how you can calculate the likelihood of buy here or likelihood of purchase here. So likelihood of buy, this is the value for the buy. So that buy divided by this, and now you will have 84, or you will have some fractional value here. And that is 84.71%. And likelihood of no purchases, this is the value for the no purchase divided by that total, you will have this one. And now if you will add them, I think it is becoming 100%. Okay. It is becoming 100%. So that erroneous thing which you have here, now it is gone there in percentage. So now this is giving me the answer that 80% is the ratio of the purchase, that okay, we are going to purchase, we are going to buy the things. So 84 is larger than this no buy, which means that average customer will buy on holiday, because here we are discussing the case of holiday with discount is equal to yes, no, or with the free delivery. Your day is what? Holiday. You have taken this example. So then what you can calculate? So an average customer will buy on holiday with discount and free delivery because the ratio is high. So this is an example of knife-based classifier, how the knife-based classifier will classify that the people can buy or not buy. And this is the next section, inshallah, we will start it in the next class. And in the next week, inshallah, it will be ended.